Let's run through the complete set of steps used to manufacture a single metal interconnect layer. First, a layer of insulating silicon dioxide is deposited onto the wafer. Next, photoresist is spread across the surface and the wafer is sent through a soft bake to remove the solvent. The wafer then travels to the photolithography tool, where the design from the photomask is transferred to each of the chips on the wafer by weakening the areas of photoresist hit by the light. The wafer next goes to the developer to wash away the sections that were hit by the light from the lithography tool, and then through a hard bake to harden the remaining photoresist. With the mask layer built, the wafer goes to an etching tool, where a plasma etcher removes a vertical column through the exposed silicon dioxide until it reaches the previous layer's metal vias. Next, the wafer is sent to a photoresist stripper, where the mask layer is removed. The wafer then travels to a physical vapor deposition tool, where a sequence of metals fills in the exposed pattern and coats the wafer in metal. Finally, the wafer is sent to a chemical-mechanical planarization tool, where the metal is ground down so that all that remains is a flat layer of insulating silicon dioxide and conductive copper interconnects that match the pattern from the photomask.